Machine learning, the magic behind your favorite recommendations on Netflix and Amazon, is the cornerstone of artificial intelligence. It's a field of computer science that allows computers to learn from experience, improving their performance as they acquire more data. Now, imagine a world where machines can predict your next move, understand your preferences, and even make decisions for you. That's the power of machine learning. Thank you for joining us here at Innovative Muse, where we explore the wonders of technology as it meets innovation. Welcome in. At its core, machine learning is divided into three parts: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is like having a teacher guiding the machine through the learning process. Unsupervised learning, on the other hand, sets the machine free to learn from the data without any guidance. And then there's reinforcement learning, where the machine learns by trial and error, constantly refining its approach to achieve its goal. Understanding these three parts gives us a foundational understanding of machine learning. Now imagine machine learning as a toolbox. The tools, those are the algorithms. Algorithms are like the secret ingredients in our machine learning recipe. Each one has its unique characteristics and uses, and together they give us the power to solve a wide range of problems. Let's meet some of these algorithms. First up is linear regression. Think of it as the simple yet reliable tool in our box. It's used for predicting a continuous outcome. For example, predicting house prices based on size. Next, we have decision trees. These are like your GPS directions for data. They ask a series of yes or no questions to split the data until they reach a prediction. Then there's logistic regression. Despite its name, it's used for classification problems, not regression. It's like a switch, flipping between two outcomes, yes or no, spam or not spam. Random forest, on the other hand, is like a team of decision trees. It combines the predictions of several trees to make a final call. It's robust and reliable, less likely to be fooled by outliers in the data. Supervector machines are the boundary setters. They find a line, or in higher dimensions, a hyperplane, that best separates different categories of data. If you've ever asked a group of friends for movie recommendations, you've used the principle behind k-nearest neighbors. It predicts a data points category based on the categories of its nearest neighbors in the data set. K means clustering is the tidy organizer of the group. It groups similar data points together into clusters, without any prior knowledge of what these clusters should be. Lastly, principal component analysis is like the Marie Kondo of algorithms. It simplifies data by reducing it to its most important features, those that spark joy, or in more technical terms, account for the most variance. These algorithms, each with their unique traits, help us solve diverse problems. So next time you're faced with a machine learning task, remember, the right tool might just be in your algorithm toolbox. Picking the right tool for the job is crucial, and the same goes for machine learning algorithms. Imagine you're a chef, and you have a kitchen full of tools. You wouldn't chop vegetables with a spoon, right? Similarly, in the realm of machine learning, we have a variety of algorithms at our disposal. The trick is to select the one that's best suited for our specific task. Let's consider some factors that influence this choice. First up, the size and quality of your dataset. You see, some algorithms perform better with large datasets, while others are better suited for smaller ones. Also, the quality of your data matters. If your dataset is riddled with errors or missing values, certain algorithms might not work as effectively. Then there's the task at hand. Are you trying to classify data into different categories, or are you predicting a continuous value? Maybe you're grouping similar data points together. These tasks require different algorithms. For instance, decision trees and support vector machines are great for classification, while linear regression works well for prediction. Computational resources are another consideration. Some algorithms are computationally intensive and might take a long time to run on large data sets. If you're working with limited computational power or under a time constraint, you might need to opt for a simpler, faster algorithm. Finally, there's no one-size-fits-all solution in machine learning. It's often a good idea to try out several algorithms and see which one performs best on your data. This is where model evaluation comes in, which we'll talk about in the next section. Choosing the right algorithm isn't just about accuracy. It's about understanding the strengths and limitations of each algorithm and aligning them with your task, your data, and your resources. It's a bit like finding the right key for a lock. Choosing the right algorithm can make the difference between a successful model and a failed one. So make sure you choose wisely. Machine learning isn't just about algorithms, it's also about the methods and practices that make them effective. It's about knowing how to work with your data, how to fine-tune your model, and how to validate its performance. Let's dive into these best practices for machine learning. Firstly, we have data processing. Data is the lifeblood of machine learning, but raw data often comes with noise, outliers, missing values, and other imperfections. Data processing involves cleaning and transforming this raw data into a more usable format. This can involve removing duplicates, dealing with missing values, and normalizing data. It's about making sure your data is as clean and consistent as possible, which helps your machine learning model make more accurate predictions. Next, there's feature engineering. Features are the variables or attributes in your data that your machine learning model uses to make predictions. Feature engineering is the process of creating new features or modifying existing ones to improve your model's performance. This might involve combining two or more features, extracting features from existing ones, or even creating entirely new features from scratch. It's a creative process that requires a deep understanding of your data and the problem you're trying to solve. Then, we have model evaluation. Once you've trained your model, you need a way to measure how well it's doing. This is where model evaluation comes in. It involves using metrics like accuracy, precision, recall, or the F1 score to assess your model's performance. These metrics can tell you if your model is overfitting, underfitting, or just right. Hyperparameter tuning is another crucial practice. Hyperparameters are the settings of your machine learning model that you can adjust to optimize its performance. This could be the learning rate, the number of layers in a neural network, or the depth of a decision tree. Hyperparameter tuning involves trying out different combinations of these settings to find the one that gives you the best model performance. Last but not least, there's cross-validation. This is a technique for assessing how well your model will generalize to an independent data set. It involves dividing your data into a number of subsets, or folds. You then train your model on all but one of these folds and test it on the remaining fold. You repeat this process for each fold, which gives you a more robust estimate of your model's performance. Applying these best practices ensures that your machine learning model is robust, accurate, and reliable. They're not just optional extras, they're fundamental steps in the machine learning process. So remember, it's not just about choosing the right algorithm, it's about how you prepare your data, how you engineer your features, how you evaluate your model, how you tune your hyperparameters, and how you validate your results. And that, my friends, is the art and science of machine learning. So why should we care about machine learning algorithms? Well, let's dive in and find out. Machine learning algorithms are more than just a collection of complex mathematical functions. They are the backbone of modern artificial intelligence systems. These algorithms are the brains behind the AI that powers everything, from your smartphone's voice assistant to self-driving cars, from predicting stock market trends to developing new medicines. Every time you ask Siri a question, every time you use Google Maps to find the quickest route home, every time Netflix recommends a movie you might like, you are interacting with machine learning algorithms. They are the silent, unseen force that makes our lives easier, more efficient, and increasingly more connected. But beyond these everyday applications, machine learning algorithms hold the promise of solving some of our world's biggest challenges. They can help us understand climate change patterns, predict natural disasters, and even unlock the mysteries of the human genome. But for these algorithms to work, for them to learn and evolve, they need us. They need our understanding, our creativity, our critical thinking. They need us to teach them, to guide them, to challenge them. And that's why understanding machine learning algorithms is so crucial. Whether you're a student just starting out, a seasoned professional looking to upskill, or simply a curious mind eager to understand the world better, learning about these algorithms can open up a world of possibilities. It's not just about understanding the technology of today, it's about shaping the technology of tomorrow. Choosing the right algorithm, processing the data correctly, engineering the right features, evaluating the model, fine-tuning the parameters, and validating the results. These are all crucial steps in the machine learning process. And understanding these steps, understanding these algorithms, is the first step towards unlocking the potential of AI. Machine learning algorithms are the gears that drive the machinery of artificial intelligence. So, keep exploring, keep learning, and let's unlock the potential of AI together. If you like this video, please give a thumbs up. We value your feedback, so feel free to leave a comment. Also, if you want to see more content like this, please share and subscribe. Until next time we meet, be well.